Fire Tower A and Fire Tower B are 1,200 feet apart. The bearing from Tower A to Tower B is 70 degrees east of north. The fire is spotted from both Tower A and Tower B at bearings of 5 degrees east of north and 10 degrees east or west of north. Now notice I already draw a little line going back to A and back to B so we can keep those straight. Find the distance from each tower to the fire. So I started by drawing a line directly from A to B, and I'm going to identify it as being 1,200 feet apart. Next, I'm going to create a Cartesian plane here. So think of this as an X and Y axis at this point. And we know that the X and Y axis are perpendicular, creating 90-degree angles. Let's start with this one, 70 degrees east of north. That's from A to B. So think of this as going directly north. So we're going to go directly north, and then we're going to swing to the east 70 degrees. So swing to the east 70 degrees. That means this measurement is 70. And since I know it creates a right angle, this measurement right here is 20 degrees. A fire is spotted from both Tower A, Tower B at the following bearings. So let's go back to Tower A. At Tower A, again, think of this as the origin, and we're going to go 5 degrees east of north to get to the fire. So we're going to go 5 degrees east of north. That means I'm going to go directly up north and then swing to the east 5. So this measurement is 5. Now all together we know this adds up to 90. We know this is 20 and this is 5. That makes this 65 because this entire angle is 70. So if I add up 5 and 65, I'm at 70, and 70 and 20 is going to make this 90 degrees. Okay, now let's go on to Tower B. So I've taken care of this measurement and this measurement. We're going to go now to Tower B, and I'm going to do the same concept. So I'm going to create right now an XY axis. This is going to be X, and this is going to be Y. So this is the origin. We know this creates 90 degrees, and it says that from B to the tower is going to be 10 degrees west of north. So I should go back and I should have put this down. This was me just assuming that everybody knows their directions. Now I've heard different students in class in the last few days use different acronyms to remember these. I was never taught that, but north, south, east is to our right, west is to our left, and we're looking straight down here at a map. Okay, so let's come back here. So we're going to go directly north first, and then we're going to swing 10 degrees to the west. So from here, I'm going to go directly north and swing 10 degrees right here to the west. Okay, so we need to figure out this measurement. Now what we know is that this creates a 90-degree angle. So if this is 10 degrees, then think again, this is like our x-axis and our y, then this must be 80 degrees. Why is that? Because 10 degrees and 80 degrees create a 90-degree angle. What is this measurement? Well, think of this, of these two parallel lines, the north markers, north and north, as being parallel lines, and they're cut by this transversal. So this measurement right here is going to be the same as this measurement right here. Or we can think of it as these two parallel lines, probably even better. These two parallel lines, and it's cut by this transversal right here. So these two measurements are opposite interior, they are equal. So this is 20. And this measurement is 70. 70 and 20 creates a 90-degree measurement, just like 80 and 10 creates a 90. Now, how does that help me out? Because the most common thing I hear from students is once I know the measurements of a triangle, I can go, oh, I did not mean to make that look like a right triangle. Once I know the measurements of a triangle, I can go back and I can easily solve it. So this angle is 80 and 20, which is 100. This angle is 65. And now I can find the third angle by simply taking 80 plus 20, that's your 100 plus, and this angles are 65. I'm going to take 180 and subtract that measurement, and we get an angle of 15 degrees. Okay, now it's time to answer the question. Find the distance from each tower to the... So I went ahead, I marked off down below as being a distance of 1,200 feet, and now I'm looking for this measurement off to the right, and I'm going to call this measurement little a. Little a is across from angle A. So I've set this up with what I know. I know the sine of 1,200 over Oops, oh my goodness, I mixed those up. The sine of angle 15 over 1200, sorry about that, equals the sine of 65 over this length A. Not to be confused there. Okay, so I'm going to cross multiply. So I'm going to start by taking sine of 65 after I ensure that I am in degrees, which I am. Sine of 65 times 1200. So 1200 times the sine of 65. And then I'm going to set that equal to this amount. And remember, to isolate the A, I'm going to have to divide by the sine of 15. So I've multiplied 1200 on my calculator times the sine of 65. And now I'm setting it equal to the sine of 15 times little a. So I'm going to need to divide by the sine of 15 to isolate little a, which is this length. So now I'm going to divide this by the sine of 15 degrees. Made a mistake there. I'm going to go back here. 1200 times the sine of 65, and now I'm going to divide that by the sine of 15. And this is my measurement. So this length right here, which is the length from the fire to Tower B, this length right here is going to be 4,202.05 feet. Another common question I had is, why can't I use the Pythagorean theorem to figure out the third side? So if I know two sides, why can't I use that to figure out the third side? Pythagorean theorem, a squared plus b squared equals c squared, can only be used with right triangles. This is not a right triangle. So I'm going to do the same concept with sine of 15 degrees over 1200 is going to be equal to the sine of 100 over this length, which we're going to call that little b. Same concept here. We're going to take 1200 times the sine of 100, and now I'm going to divide it by the sine of 15. And this length, which would be from Tower A to the fire, right here, is going to be a length of 4,566.01 feet.